Cara, eu não preciso. Você não. Cara, eu não tinha. Segundos. Ele é absurdo. Você não. Muito tempo de delay, velho. Tempo de delay é absurdo. Eu não vou ficar com delay.
To the puzzle piece. Anything inside of those curly braces is going to be equivalent to anything inside of this yellow hug that's sort of grabbing one or more pieces inside. So what do we put inside? Well, this part is straightforward. Printf, quote unquote, x is less than y, \n, semicolon. So nothing new here. The only bit of new code is this if construct instead. What if you have an if else? So a two-way fork in the road. This is what that looked like in Scratch. Same question, if x is less than y, then say x is less than y, else say x is not less than y. In C, the code is going to be set up initially like this. So two sets of curly braces to represent this pair of yellow bars and this pair of yellow bars. And what's inside of them, indented no less, just like our pseudocode last week, is two printfs. X is less than y, x is not less than y. So that's it. So the only new stuff here really is now the else keyword, which does not need parentheses because you're just saying else do this other thing. But what if it's a three-way fork in the road? And we'll stop after that. Here's a three-way fork in the road in Scratch. If x is less than y, then say this. Else, if x is greater than y, say this. Else, if x equals y, then say this. So this is a little more precise because now at first glance, especially if you've never programmed before, it looks like I'm an idiot and I made a typo. What looks wrong? There's like two equal signs, like not a typo. So it turns out, recall from earlier, when we used the equal sign the first time around, we used it in the context of getting a return value back from a function, like the getString function handed me back the user's answer. So unfortunately, because humans decades ago decided, hey, let's use the equal sign to assign a return value from the right-hand side of a line of code to the left-hand side, we sort of painted ourselves into a corner and like, oh, shoot. What do we do when we actually want to test for equality of two values on the left and right? So what most languages, including C, do is use double equal signs. So you can say double equals or equals equals or whatever, but it is in fact syntactically correct. What's inside of these three sets of curly braces? Same idea, printf, 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 based on what English phrase you want to print out. So this code, both in Scratch and C, I'll claim is correct. It won't run because we still need like the other stuff, the equivalent of the when green flag clicked. But out of context, this code is correct. But there's a subtle weakness in design. And we'll talk a lot about this week and beyond. Correctness just means the code does what it's supposed to do. Design is more subjective. Like how well have you written your argument in an English paper? How well have you written your code is design. This code is not designed as well as it could be because I'm doing more work than I need to. Yeah, and back. Yeah, I don't need the x equals y, but why, logically? Exactly. That's just a math thing. Like either x is less than y or it's greater than y, or the third and final option is they must be equal. So it's subtle, but why would you bother wasting time writing a line of code and expecting the computer to run a line of code that is just going to answer a question that logically you could have concluded already? Because if x is not less than y, and x is not greater than y, then my God, just print out x is equal to y, because you know at that point, logically, it's true. You don't need to waste your time or the computer's asking a third question unnecessarily. In reality, it's not a huge deal. No one's going to notice in the real world on a Mac or PC that there's this extra line of code, but it's a bad habit. Keep it simple. Don't write code that doesn't need to be there if logically you can conclude otherwise. So in fact, let's clean this up both in Scratch and in C. I can tighten this up, so to speak, use less code here, less code here, and honestly, if only statistically, the less code I write, the less likely I am going to make mistakes. So that too is probably a net positive overall. Writing less code is generally better than writing more code, not unlike English essays too, perhaps. All right, questions about can tighten this up, so to speak, use less code here, less code here, and honestly, if only statistically, the less code I write, the less likely I am going to make mistakes. So that too is probably a net positive overall. Writing less code is generally better than writing more code, not unlike English essays too, perhaps. All right, questions about this feature of C, conditionals, and this syntax? Yeah. Oh, a really good question. And yes, jumping the gun, there are alternative ways to solve problems like these. And the question was, to summarize, when to use if, else versus what's called a switch statement. More on those another time. But this is going to be true in general in programming, not just C, not just in Scratch, but every language. There are going to be several, dozens, hundreds, an infinite number of ways to solve problems. Among the things we're going to teach you, though, is indeed how to do things well or better than you might otherwise. And we're going to introduce you eventually to another feature of the language that can even simplify this code too. So for now, let's actually use this then. So let me go over to VS Code again. I'm going to go ahead now and clear my terminal window. Down here, I'm going to go ahead and close the hello.c tab, just so that we're going to create a new program. And let's just do something a little simple using some operators, so to speak. And I haven't used this word by name, but it turns out that there's lots of operators that come with C, just like a lot of operators that came with Scratch for doing assignments. Or less than or equal to, greater than or equal to, actually equal to, not equal to. Now, some of these are a little cryptic, but there's no easily found key on your US English keyboard, at least, where you can do less than or equals or greater than or equals. So what most programming languages do is you don't use a special symbol where there's like an angled bracket and then a line below it. You actually just use two characters. So greater than or equal is literally this, this. Less than or equal is literally this, this. We already saw that equals is this, this. And not equals is to use an exclamation point. So this too is a thing in programming. Using the exclamation point, pronounced bang, is how you invert logically certain things. So bang equals or not equals is how you would express exactly that idea. It's just a symbol on the keyboard that some human decided, let's use this one to invert the idea. But we're going to need one other thing for this program, specifically variable. Already, sort of because in Scratch we got one for free. We had that answer variable that stored the return value of the ask block. But let's consider in general how you can, and probably did for problem set 0, use a variable of your own, like keeping track of a counter or a score or the like. In Scratch, if you want to create a variable called counter, you can set it equal to some initial value like 0. In C, that code's going to look similar. You literally just write whatever name you want to give the variable, then an equal sign, and then the value you want to give that variable. And because the equal sign is the assignment operator, it will behave essentially right to left and copy the 0 into counter. But this isn't enough for C. Remember that you, the programmer, have to tell the computer, is this indeed a number? Is it a letter? Is it an image? Is it a sound? You have to tell the computer that this is an integer, otherwise written as int for short in C. But there's one other stupid detail that's missing, which is now semicolon to finish the thought here. But this then is equivalent to this in Scratch. Let's do another. In Scratch, if you wanted to increment the counter, that is add 1 to it, you could literally use this puzzle piece here and specify you want to add 1. In C, it's going to look like this. Counter equals counter plus 1 semicolon. Now at a glance, this is 1 to semicolon to finish integer the thought here. But this then is equivalent to this in Scratch. Let's do another. In Scratch, if you wanted to increment the counter, that is add 1 to it, you could literally use this puzzle piece here and specify you want to add 1. In C, it's going to look like this. Counter equals counter plus 1 semicolon. Now at a glance, this seems like a paradox of sorts. Like, how can counter equal counter plus 1? Like, I can't make that math expression true, but it's not math in this case. The single equal sign is assignment. So this means take the current value of counter, whatever it is, add 1 to it, and then copy that value from right to left into the same variable, thereby changing it from 1 to 2, 2 to 3, and so forth. This, though, is so common in programming to be able to increment or even decrement numbers by 1 or 2 or more, is that you can tighten it like this. This is the exact same thing, a little faster to type, saves you keystrokes, maybe less chance for error. Counter plus equals 1 semicolon is the exact same idea. Better still, this is so common in C and C++ and Java that there's a programming to be able to increment or even decrement. Return value of the ask block. But let's consider in general how you can, and probably did, use a variable of your own, like keeping track of a counter or a score or the like. In Scratch, if you want to create a variable called counter, you can set it equal to some initial value like 0. In C, that code's going to look similar. You literally just write whatever name you want to give the variable, then an equal sign, and then the value you want to give that variable. And because the equal sign is the assignment operator, it will behave essentially right to left and copy the 0 into counter. But this isn't enough for C. Remember that you, the programmer, have to tell the computer, is this indeed a number? Is it a letter? Is it an image? Is it a sound? You have to tell the computer that this is an integer, otherwise written as int for short in C. But there's one other stupid detail that's missing, which is now semicolon to finish the thought here. But this then is equivalent to this in Scratch. Let's do it. or score or the like. In Scratch, if you want to create a variable called counter, you can set it equal to some initial value like 0. In C, that code's going to look similar. You literally just write whatever name you want to give the variable, then an equal sign, and then the value you want to give that variable. And because the equal sign is the assignment operator, it will behave essentially right to left and copy the 0 into counter. But this isn't enough for C. Remember that you, the programmer, have to tell the computer, is this operator? It will behave essentially right to left, then an equal sign, and then the value you want to give that variable. And because the equal sign is the assignment operator, it will behave essentially right to left and copy the 0 into counter. But this isn't enough for C. Remember that you, the programmer, have to tell the computer, is this indeed a number? Is it a letter? Is it an image? Is it a sound? You have to tell the computer that this is an integer, otherwise written as int for short in C. But there's one other.
Oh, boy.
About this feature of C, conditionals, and this syntax. Yeah. Oh, a really good question. And yes, jumping the gun. There are alternative ways to solve problems like these. And the question was, to summarize, when to use if, else versus what's called a switch statement. More on those another time. But this is going to be true in general in programming, not just C, not just in Scratch, but every language. There are going to be several, dozens, hundreds, an infinite number of ways to solve problems. Among the things we're going to teach you, though, is indeed how to do things well or better than you might otherwise. And we're going to introduce you eventually to another feature of the language that can even simplify this code, too. So for now, let's actually use this then. So let me go over to VS Code again. I'm going to go ahead now and clear my terminal window. Down here, I'm going to go ahead and close the hello.c tab, just so that we're going to create a new program. And let's just do something a little simple using some operators, so to speak. And I haven't used this word by name, but it turns out that there's lots of operators that come with C, just like a lot of operators that came with Scratch for doing assignment, or less than or equal to, greater than or equal to, actually equal to, not equal to. Now, some of these are a little cryptic, but there's no easily found key on your US English keyboard, at least, where you can do less than or equals or greater than or equals. So what most programming languages do is you don't use a special symbol where there's like an angled bracket and then a line below it. You actually just use 2 characters. So greater than or equal is literally this, less than or
Presta atenção nisso. Desodorante. Vou passar um desodorante. Mas até tudo aqui. Já perdi. 4 segundos. Não é possível. Vou passar um desodorante. Já perdi. 4 segundos. Não é possível. Vou passar um desodorante. Mas essa aqui é olha,
that allow you manually to make different versions of your code. Uses parentheses like most languages. And
como você pode ficar aqui? Por exemplo, eu quero mudar minha vida. Voltei, voltei. Isso aqui. Salada.
this. We already saw that equals is this. And I haven't used this word by name, but it turns out that there's lots of operators that come with C, just like a lot of operators that came with Scratch for doing assignment, or less than or equal to, greater than, greater.
Okay, let me see. I igual equal. Nossa, um, what's this?
Than or equal to, not equal to. Now, some of these are a little cryptic, but there's no easily found key on your US English keyboard, at least, where you can do less than or equals or greater than or equals. So what most programming languages do is you don't use a special symbol where there's like an angled bracket and then a line below it. You actually just use two characters. So greater than or equal is literally this. Less than or equal is literally this. We already saw that equals is this. And not equals is to use an exclamation point. So this too is a thing in programming. Using the exclamation point, pronounced bang, is how you invert logically certain things. So bang equals or not equals is how you would express exactly that idea. It's just a symbol on the keyboard that some human decided, let's use this one to invert the idea. But we're going to need one other thing for this program, specifically variables, which we've used already sort of people on the use a special, but there's no easily found key on your US English keyboard, at least, where you can do less than or equals or greater than or equals. So what you just do is you don't use a special symbol where there's like an angled bracket and then a line below it. You actually just use two characters. So greater than or equal is literally this. Less than or equal is literally this. We already saw that equals And not equals is to use two characters. So greater than or equal is literally this, this. Less than or equal is literally this, this. We already saw that equals is this, this. And not equals is to use an exclamation point. So this too is a thing in programming. Using the exclamation point, pronounced bang, is how you invert logically certain things. So bang equals or not equals is how you would express exactly that idea. It's just a symbol on the keyboard that some human decided, let's use this one to invert the idea. But we're going to need one other thing for this program, specifically variables, which we've used already sort of because in Scratch we got one for free. We had that answer variable that stored the return value of the ask block. But let's consider in general how you can, and probably did for problem set 0, use a variable of your own, like keeping track of a counter or a score or the like. In Scratch, if you want to create a variable called counter, you can set it equal to some initial value like 0. In C, that code's going to look similar. You literally just write whatever name you want to give the variable, then an equal sign, and then the value you want to give that variable. And because the equal sign is the assignment operator, it will behave essentially right to left and copy the 0 into counter. But this isn't enough for C. Remember that you, the programmer, have to tell the computer, is this indeed a number? Is it a letter? Is it an image? Is it a sound? You have to tell the computer that this is an integer, otherwise written as int for short. One other stupid detail that's missing, which is now semicolon to finish the thought here. But this then is equivalent to this in Scratch. Let's do another. In Scratch, if you wanted to increment the counter, that is add 1 to it, you could literally use this puzzle piece here and specify you want to add 1. In C, it's going to look like this. Counter equals counter plus 1 semicolon. Now at a glance, this seems like a paradox of sorts. Like, how can counter equal, want to add this in Scratch? Let's do another. In Scratch, if you
sounds like
to give the variable, then an equal sign, and then the value, some initial value like 0. In C, that code's going to look similar. You literally just write whatever name you want to give the variable, then an equal sign, and then the value you want to give that variable. And because the equal sign is the assignment operator, it will behave essentially right. Copy the 0 into counter. But this isn't enough for C. Remember that you, the programmer, have to tell the computer, is this indeed a number? Is it a letter? Is it an image? Is it a sound? You have to tell the computer that this is an integer, otherwise written as int for short in C. But there's one other stupid detail that's missing, which is now semicolon to finish the thought here. But this then is equivalent to this in C, in Scratch. Let's do another. In Scratch, if you wanted to increment the counter, that is add 1 to it, you could literally use this puzzle piece here and specify you want to add 1. In C, it's going to look like this. Counter equals counter plus 1 semicolon. Now at a glance, this seems like a paradox of sorts. Like, how can counter equal if you want to add this in Scratch? Let's do another. In Scratch, if you wanted to increment the counter, that is add 1 to it, you could literally use this puzzle piece here and specify you want to add 1. In C, it's going to look like this. Counter equals counter plus 1 semicolon. Now at a glance, this seems like a paradox of sorts. Like, how can counter equal counter plus 1? Like, I can't make that math expression true, but it's not math in this case. The single equal sign is assignment. So this means take the current
Actually, the equal, it's different. This counter, it's the variable, and this other counter, it's the new one.
current value of counter, whatever it is, add 1 to it, and then copy that value from right to left into the same variable, thereby changing it from 1 to 2, 2 to 3, and so forth. This, though, is so common in programming to be able to increment or even decrement numbers by 1 or 2 or more, is that you can tighten it like this. This is the exact same thing, a little faster to type, saves you keystrokes, maybe less chance for error. Counter plus equals 1 semicolon is the exact same idea.
One is see? Jimmy, assim, ah, persist-
Yeah. Better still, this is so common in C and C++ and Java that there's a third way to do this. To my comment earlier about solving problems in different ways, the most canonical, the most popular way is probably just to say counter plus plus semicolon, which literally automatically adds 1 to that value. Only works for 1. If you want to do 2 or 3 or some other increment, you have to use one of the other approaches. But this simply does the same thing as this. And if you want to invert it to -1, you change the plus plus to a minus minus instead. So again, just little things that we'll see and pick up over time. Invariably, you'll have to look them up or check the notes or look back at the lecture slides. But in time, this will get familiar if you are not already familiar. So let's consider just logically how we might implement this in code. Let's go back to VS Code here, and let me propose that we create a program called compare.c, whose purpose in life is just to compare a couple of values. I'm going to go ahead and proactively, based on the previous chats, include CS50's library from the get-go. I'm going to include standard io.h from the get-go, so I can use getInt and printf respectively. I'm going to just on faith type int main void, and today we won't explain what that does. More on that to come.
Canal do Rolinan, eu adoro mamãe.
Anônimo mandou R$ 2,01. Olha rapidinho, o Funk Black Cat fez uma referência a você. Mandou R$ 2. Sou campeão mandou R$ 2,10. Sou campeão, campeão em dar abraços e beijinhos, Renan, estou calientinho, a cada dia que passa você está mais lindo.
O Funk Black Cat fez uma referência a você. Um vídeo de 26 minutos. Não tinha como tu mandar a minutagem não, meu nobre. Eu sei que isso é pedir demais, é tipo querer tudo na mão, mas não pensa em mim não, pensa na galera. Porque eu acredito que o nome Pragmata, a referência dele foi o nome do jogo. Tá que o pariu, mano. É por isso que eu falo que a live não é de react. Vai tomar.
Opa, saiu a demo do Pragmata, novo jogo da Capcom, vamos dar uma jogada aqui. Pra quem não viu, esse jogo é um jogo de tiro em terceira pessoa, que se passa no espaço, dentro de uma nave, tu controla o cara e dá tiro nos robôs. Aí uma menininha fica no teu ombro, estilo Little Sister no Big Daddy, e ela vai hackeando os inimigos pra deixar eles mais vulneráveis. Então é uma combinação de elementos interessante, eu tô curioso. Direto na ação, aí sim, mano. Eu gosto dessas demos da Capcom Evil. Tem pra ela botar o... Tem uns lugarzinhos pra ela botar o pé ali, mano. Hackear inimigos. Alcance o nó do ESE para hackear inimigos. Mova o cursor pela matriz de hackeamento, conecte-se ao nó do ESE. Reaja ao Léo Stronda sendo atropelado por um avião no GTA San Andreas. Mano, eu já vi esse vídeo, tá? Eu vou ver de novo aqui. Ele é incrível mesmo. Se isso tivesse acontecido comigo, seria um dos dias mais felizes da minha vida.
I'm back. I'm back. I'm back. I'm back. I'm back. I'm back. Como é que vai passar bem aqui? Isso. Parar aqui quando I'm back. Yes.
Like when green get int and printf respectively. I'm going to just on faith type int main void. And today we won't explain what that does. More on that to come. For now, just assume it's like when green flag clicked. But in this program, let's do a couple of things. Let's declare an integer called x and assign it the return value of getInt. And let's just keep it simple. Let's ask the user not what's their name, but what's the program. I'm going to just, on the previous chats, include CS50's library from the get-go. I'm going to include standardIO.h from the get-go, so I can use getInt and printf respectively. I'm going to just on faith type int main void. And today we won't explain what that does. More on that to come. For now, just assume. assume it's like when green flag clicked. But in this program, let's do a couple of things. Let's declare an integer called x and assign it the return value of getInt. And let's just keep it simple. Let's ask the user not what's their name, but what's x question mark, semicolon. Now, so that we have something to compare, let's do it again, but with y. Int y equals getInt, quote unquote, what's y question mark. And I'm leaving, again, a space just visually so the cursor nudges over a bit, followed by a semicolon. At this point in the story, my users will be prompted for x and y respectively. Let's do something with those values. How about nudges over a bit? Let's do it again, but with y. Int y. And let's just keep it simple. Let's ask the user not what's their name, but what's x question mark, semicolon. Now, so that we have something to compare, let's do it again, but with y. Int y equals getInt, quote unquote, what's y question mark. And I'm leaving, again, a space just visually so the cursor nudges over a bit, followed by a semicolon. At this point in the story, my users will be prompted for x and y respectively. Let's do something with those values. How about if x is less than y, then go ahead. Quote unquote, x is less than y backslash n, close quote, semicolon. All right, and let me hide my terminal window for just a moment. This is a 13-line program at the moment, but really it's like 5 or 6 interesting lines. The rest has been copy-paste from previous programs. Notice I've indeed used my curly braces here. And notice if you highlight lines, you'll actually see little dots that can help you make sure, oh, there are indeed 4 spaces there. I've been indenting, just like we did last week with pseudocode. Strictly speaking, it's not necessary, but it's going to be way easier to read your code if you do add all of this white space, so to speak, than if you write and then submit to us as homework a program that looks sort of god-awful like this, which is going to make it much, much harder for the human to read it, for you to read it, your colleagues in the real world to read it, but the computer is actually not going to care. In fact, as an aside, one of the tools we have built into VS Code for CS50 is this button at top called Style50. This is a program that we indeed wrote that will give you suggestions on how to improve the style of your code so it looks like the right way that programmers would generally write it. As an aside, the computer world is fraught with like religious debate, so to speak, as to like what code should look like. And people in the real world will have really stupid arguments over how many spaces to use for indentation and what lines code should go on and so forth. Generally, in the real world or in a class, there's an official style guide that someone sort of autocratically declares this is how everyone should write their code, so that just everyone's code in the company or course looks the same. But you'll find in the real world, reasonable people will disagree. When you click Style50, it will be formatted as we ourselves recommend in CS50. And in fact, let me zoom out here. And this looks a little cryptic at first glance, but on the left is the code that I just
mais fácil.
Wrote and made a mess of by deleting all that white space. On the right is the way the code should look if it is well styled. So whereas correctness is all about, does the code work the way it's supposed to? Design is about, how well have you written that code? Is it efficient? Did you make good decisions? Style is purely aesthetic. Is it readable? Does it follow a standard? Can another human sort of easily skim it top to bottom, left to right, and understand what's going on? So these green highlights are saying, please add white space there. And so I can actually change my code to match. On the left-hand side here, if I realize, oh, my code's looking pretty ugly, watch on line 6 at left as I hit the space bar to, whoops, sorry, on the left, 1, 2, 3, 4. Notice that the right-hand side is starting to be happier with my code by getting rid of the green indicators. And I can do 1, 2, 3, 4. That fixed that. Over here, I can do 1, 2, 3, 4. I can move this onto its own line by hitting Enter. And you know what? If it's taking too long, once you get into the habit of things, you can just apply changes. It will give you the suggestions automatically, and we're done and on our way. But for practice's sake, I would get into the habit of doing things manually until it gets boring and tedious, and at which point you might as well automate the process with a single click. All right, so let's actually run this code. I'm going to go ahead and open my terminal window again and clear it for clarity. I'm going to run make compare and hope that I didn't make any mistakes. I don't seem to have yet. /compare, and now notice I'm prompted for x, let's type 1. For y, let's type 2, enter, and x is less than y. Let's do a little sanity check, so to speak. Let's rerun it. /compare. What's x? Let's do 2 this time. 1 for y. And this time it said nothing. So that's to be expected, because I didn't have a 2-way or a 3-way fork in the road. The only time this code should say anything is if indeed x is less than y. So for those of you who might be more visual when it comes to learning, here's a flow chart that represents this same exact program. If you read it top to bottom, you start the program with /compare. You are then prompted for x and y. And you're asked this, is x less than y? And the fact that this is a diamond means this is a Boolean expression, a question that the computer is asking itself.
seus cornos, mano. Vacilão.
Ah, e pra completar, Alexandrina, que dá vagina.
E aí, Elvis, como é que você tá?
Ah, meu Deus, cara.
Then prompted for x and y, and you're asked this: is x less than y? And the fact that this is a diamond means this is a Boolean expression, a question that the computer is asking itself. If the answer to that question is true, then quote unquote x is less than y gets printed, and the program stops. Else, if x is not less than y, as in the second scenario, the answer is, of course, false, and nothing more happens. But we can build out this tree, so to speak, by adding a bit more code. So let's make it look like the second Scratch example. If I go back here, it's not hard to just say else if x is not less than y, let's say that. X is not less than y backslash n, close quote, semicolon. Let me now go ahead and rerun, make, compare.
Vai. Ah, problema. Eu não tenho essa. Sim. Se não for assim, se eu for necessariamente não vai. Não, não, não. Se você me fala assim, não é que Então, esse aqui tá cá embaixo. Tá aqui. É Ctrl Z. Não dá pra ver. Aí, pronto. Tá errado. Não tem, cara. Cagado. else, é isso, cara. Isso, cara. Assim, lá em cima. Esse é mais. Espaço. É muito tá espaçado. Foi. Foi também. Eu acho que deu certo. Isso aqui parece que eu não tenho certeza. Esses lá vão. Sério. Isso. Não. É isso, cara.
/compare, enter, and again, I'll do the second example. 2, which is bigger, and 1, which is smaller. And this time, I will see x is not less than y. If then we were to look not at this flow chart, but a slightly bigger one, you can sort of visualize it this way. Everything on the left-hand side of this picture is the same. But if it's not true that x is less than y, the answer is thus false. This time we say, quote unquote, x is not less than y. And we can do this obviously one final time just to bring the point home. If I go back to my code and I even more pedantically compare these three values, let me go ahead and do this. So else, I don't want an else actually, so let's go ahead and do this. Else if x is greater than y, let's then say x is greater than y in English, and then finally have an else that says print f x is equal to y, close quote, or rather backslash n, close quote, semicolon. So just to show this all on the screen at once, this is identical.
AI said that I had to do that. There's a person that is the normal way. Okay, it's good. If didn't did 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 not show anything here, it's right. It's combined right, and it means that the comment it's better. The comment it's in a better situation. So if I do make the is a comment, let me see if my camera is exposed. It's not. It, it's a make and don't show any error, error, error like this. It's right. You didn't fail and make my code right. Didn't make any error like this. That's right. In my head, it did not show anything. Anything. I, I think that there is something is wrong. Something is wrong. Something is wrong. That's terminal, um,
Scratch version, it's well equal to y, close quote, or rather backslash n, close quote, semicolon. So
let me test it first. So I'm watching the class. Besides Q2. Yes, it's right. It's right. I made it right. I made it right.
It once. This is identical now to that Scratch version. It's well designed because I'm not asking the equals question unnecessarily. If I go back to my terminal window here, clear the screen, run make compare, enter, and then /compare again, enter. What's x? Let's do 1. Let's do 2. X is less than y. Let's run it again. /compare. What's 2 and 1? X is greater than y. Once more time. /compare. What's x1? What's y? 1. And now x is equal to y. As an aside, if I seem to be typing fairly fast, you can actually kind of cheat with your keyboard. If you go up or down, you can scroll through all of the past commands that you've typed. So it's actually, very useful. If you just hit up, it will pre-write the previous command for you, at which point you can just say enter. Or there's other fancy features built into this programming environment. If you do ./com and then get kind of bored with typing out the whole English word, you can hit tab for tab completion, like in a web browser, and it too will auto-complete if it finds a file that starts with those letters. So little efficiencies here. Questions then on the code here? Yeah? Sure. A good question. Is there any downside to just putting in all of the libraries like we saw in the manual pages a moment ago? Performance. So generally speaking, C is meant to be a very efficient language, so much so that even though it's decades old, still used omnipresently nowadays because it's so fast. It therefore minimizes time, it minimizes energy use, so it's still being used heavily. You would slow things down if you told the compiler, by the way, give me all of these other functions that I'm never going to use. So in short, just don't do that because it's unnecessary. But a good question. Other questions on what we've done here? Yeah, in front. What is it? Why is C faster? Why is C faster than other languages? Let me answer that in more detail in week 6 when you'll see how much easier it is to write code in other languages because someone else is doing a lot of the work for you. So as an introductory course, we're sort of teaching you bottom up, like how do you write code? How does the computer understand code? Eventually, this kind of stuff, certainly after like 5-6 weeks of this, it's going to get tedious doing some of these things. We're going to switch to another language that takes away the tedium and allows us to really focus on the problems to be solved once we've sort of graduated to that point. Yeah? Sure, to repeat the keyboard shortcuts, you can just go up, 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 and that will go through all of your previous commands, at which point you can just hit enter. Or you can use tab completion. So you can start typing a word like code, and COD tab will finish the thought, or /com tab will finish that thought, just to save yourself some keystrokes. And clearing the screen is Control L, which has no functional purpose other than keeping things neat and tidy in class. So a design question. So this code, I dare say, is correct. Let me zoom in a little bit here. Let me change the code to just do this, even though we already saw from scratch that we probably shouldn't do this. Why should we not do this if, especially, I'm just more comfortable asking 3 separate questions, like if x is less than y, if x is greater than y, if x equals y, do this. Like, it's a nice world to live in. Just ask your questions. You don't have to worry about else if, forks in the road. You can just ask 3 questions. But let's put a finger on why is this correct, yes, but not well designed. Yeah, and back again. OK, there could be cases that are potentially outside of these 3. Because this is relatively simple math comparing numbers, like we don't have to worry about that here. But yes, in general, you might miss a scenario without using a catch-all like else. Yeah, so maybe more than one of them could be evaluated as true. Not going to happen here, but yes, you could accidentally create a situation where 2 things print or 3 things print because you didn't really think about the boundaries among these questions that you're asking. Again, not applicable here, but in general, a good concern. Really good. Really what's concerning here in this example is you're slowing the computer down by wasting its time having it do work that is logically unnecessary, even more so than the scratch in the first C example. Why? Suppose that I type in 1 for x and 1 for y. Because I wrote this code top to bottom, this question is going to be asked no matter what. The answer is going to be false. This question is going to be asked no matter what. The answer is going to be false. This question is going to be asked, and no matter what, the answer is going to be true. We're OK there because we had to ask all 3 questions. But suppose I did the first thing. X is 1, y is 2. Then this first question is going to be true because x is less than y, 1 is less than 2. So this is going to print. And yet then I'm wasting everyone's time asking, is x greater than y? Even though it obviously isn't. Is x equal to y? It obviously isn't. You're adding you're doing 3 times as much work in that particular case. It's just not good design. And again, for those of you who think a little more visually, we can actually make this picture to match. Here is a final flow chart for bad code, bad design. Why? Because no matter what, when you start the program and you want to stop the program, you're going through all 3 of those darn questions no matter what. Whereas the previous flow charts got us to the stop bubble faster by taking alternative arrows based on true or false answers. So in short, still correct, but bad design. And so again, even for problem set 1, when we start writing C code, consider not just getting the job done, but how you might get the job done better than you might otherwise. All right, let's add a few other features into the mix. Here we have those same data types that are supported by C. Let's focus for a moment on something a little simpler, just chars, single characters. Unfortunately, for better or for worse in C, the language makes a distinction between strings of text, which are generally words, phrases. They can, confusingly, be single characters or even 0 characters if you don't type anything in between the quotes, but more on that another time. But when you know from the get-go that you only want to get a single character back from the user, like Y for yes, N for no, for instance, which is super common in programs, you can get that using a char and CS50's own function, getChar. So how might we use this? Well, let's go back to VS Code here. I'm going to close compare.c, and let's write a third program altogether. Let's call this one agree.c. And this is meant to represent like terms and a box yes or no or something like that. In this program, I'm going to go ahead and do the following. I'm going to go ahead and, as before, include cs50.h, so we've got it. Include standard.io.h, so that we've got it. Int main void, because we have to do that for now. More on that another time. And now let's ask the user a question. Do they agree? So I'm going to call get char, and then pass in a prompt of do you agree question mark with a space, semicolon. But as before, with getString and getInt, those functions return a value. So I want to assign that value from right to left to a variable, which I could call answer again. But honestly, this program's so short, we're just going to use the letter C, which is conventional. So C for char, I for int, or N for number are very common. But one more thing, what's still missing for my variable here? The type. I need to say this shall be a char, not an int, not a string, a single char. All right, now what do I want to do? I can ask a question. If C equals lowercase y, then go ahead and print out, just so we see something on the screen, agreed period backslash n, as though they agreed to the.
All right.
Else, if C equals lowercase n, go ahead and print out, for instance, not agreed backslash n, as though they agreed to the terms and conditions. Else, if C equals lowercase n, go ahead and print out, for instance, not agreed, just so we see something on the screen. So let me hide my terminal window and focus on the code. There's a couple of details here that are a little interesting. So one, what did I do on lines 7 and 11 that is not consistent with what I've done before? Subtle. So I'm using apostrophes or single quotes now instead of double quotes. Why? It's a C thing. When you're using strings, you use double quotes. When you use single chars, you use single quotes. So the argument to getChar, that's still a string. It's a whole sentence that I'm passing in. So that is just like getInt, just like getString. But when I get the answer back, the return value, and put it in this variable, and I want to check what is that one char, I have to surround the char I'm comparing against in single quotes or apostrophes, both for the y and for the n. So this program's not super well designed because it's not going to handle uppercase. It's not going to handle weird inputs very well. But let me open my terminal window, make agree, enter. The code compiles OK. Well designed is that one char.
assim, I haven't done Vamos ver aqui. Make review. Parênteses, né? Esqueci de ver aqui. Não, esqueci. Agora eu vou. Só preparando de volta. Porque aqui é assim, tipo, eu queria. Ah, comparação de prioridades. Aí vai ter duas comparações. Aqui é muita diferença.
Around the char I'm comparing against in single quotes or apostrophes, both for the y and for the n. So this program's not super well designed because it's not going to handle uppercase. It's not going to handle weird inputs very well. But let me open my terminal window, make agree, enter. The code compiles OK, /agree. Do I agree? Let's try it. Y for yes. OK. Let's try it again. /agree. N for no. Not agreed. Let's do it one more time. Let's very enthusiastically say yes in all caps. And it just kind of ignores me. But why? Well, this is a feature of CS50's getChar function. If you tell us you want to get a char, we're not going to tolerate a whole string of text from the user. We're going to prompt them again and again and again until they give us just one char. So yes is 3 times too long. So let's actually just do a single capital Y and see what happens. Return. The program ignores me altogether. So all right, this is kind of a poorly designed program. It's a little annoying that we'll just ignore humans, even if they type in Y or N that just happens to be uppercase. So let's improve this. Let me go ahead and add a couple more conditions. Else if C equals uppercase Y, then go ahead and print out agreed, same as before. And then down here, else if C equals capital N, then let's go ahead and print out again, not agreed.
Aí eu preciso explicar para você.
To be uppercase. So let's improve this. Let me go ahead and add a couple more conditions. Else if C equals uppercase Y, then go
Why?
same as before. And then down here, else if
Exactly.
Capital N, then let's go ahead and print out again, not agreed. So this is now more correct. It's still going to ignore bogus input. That makes no sense if it's just like the word, if it's a different letter altogether. But this to code, while more correct in some sense, is still poorly designed. Even if you've never programmed before, what rubs you the wrong way about this code now? Be critical. Yeah. Yeah, it'd be nice to just merge the lowercase and the uppercase y together. The same thing for the lowercase and the uppercase n. Why? If only because like literally lines 9 and 12 are identical. Lines 17 and 21 are identical. And while not a huge deal, you know, if I go in and I change this sentence, odds are over the course of my lifetime programming, I'm going to forget to change this one even though I changed this one. Or I'm going to forget to change this one and this one. So you don't want the code to get out of sync potentially. And you certainly don't want to repeat yourself. So don't repeat yourself is a tenet of programming too. If you can avoid that by somehow factoring out some commonality, you should do so, similar in spirit to math when you factor out variables or the like. So let me tighten this up, so to speak. Let me get rid of what we just did so that it's a little shorter as before. And let me express myself with two conditions using the following syntax. I want to check if c equals lowercase y or c equals uppercase y. So you can actually use what's called a logical operator, two vertical bars, which means or, lowercase, so that it's a little shorter as before. And let me express myself with when you factor out variables or the like. So let me tighten this up, so to speak. Let me get rid of what we just did so that it's a little shorter as before. And let me express myself with two conditions using the following syntax. I want to check if c equals lowercase y or c equals uppercase y. So you can actually use what's called a logical operator, two vertical bars, which means or, and we can do this down here, or c equals capital N. So same. I want to check if c equals lowercase y or c equals uppercase y. So you can actually use what's called a logical operator, two vertical bars, which means or, and we can do this down here, or c equals capital N. So same exact functionality, but to your point, we've now eliminated what, like another one, it was like what, 4, it's like 8 lines of code now. Now are gone, which is 8 fewer lines that I might screw up in this program, less opportunity for mistakes or bugs, Probably a good thing. So now if I run this, let me open my terminal window. Let me run make agree, enter, /agree, enter. Do I agree? Capital Y. Now it seems to be handling both of those situations. So just a little tighter. As an aside, we won't use it here, but if you want to say and, which would be nonsensical, it, a little confusingly, is 2 ampersands, means a logical and, whereby the left thing has to be true and the right thing has to be true. So it's 2 Boolean expressions at once. This one makes no logical sense, though, because a character cannot be simultaneously lowercase and uppercase. It's got to be one or the other. So 2 vertical bars is logically correct. That represents our notion here of or. Question? No? Yeah? You could not write or. So I'm saying or just because that's a little more normal, but this is incorrect. However, sneak preview, in the language of Python, you actually will literally say or among other things, which gets a little more user-friendly. Other questions on this here? Searching? Yes, in back. Is there an easier way to handle case sensitivity? Yes, and we'll show you that next week, in fact. So we can combine this code to be even tighter. All right, let's do one final set of examples before taking a cookie break, if we could. But let's go ahead and close agree.c here. Let me open my terminal window, and let's go ahead and implement a sort of virtual cat as we did last. last week. I'm going to code up a file called cat.c, and I'm going to implement this in a few different ways, the first of them pretty foolish. So here, I'm going to include standard.io.h, no need for cs50 just yet, int main void. Inside of these curly braces, let's go ahead and do printf meow to get the cat to meow. And then to save time, I'm going to copy paste that 2 more times. So this cat shall meow 3 times in total. All right, I'm going to go ahead and make the cat, so to speak. All good. /cat, enter, and it meows 3 times, just like our scratch cat last time. I'll stipulate this is correct. This is a really well implemented cat, correctness-wise, but why is it bad design intuitively, just like last week? Sorry? I keep repeating the code. I mean, I literally copied and pasted, which is sort of your first obvious sign. I'm probably doing something wrong if I'm copying and pasting, because I'm literally repeating myself. So to spoil it, like odds are a loop is probably going to be our friend here. And so in fact, in C, we have those features as well. So in the world of C, we can implement some of last week's same ideas in a few different ways. These are a little more mechanical, but suppose we want to repeat something literally 3 times. Scratch gives us a repeat block with an input, so easy. C, and a lot of languages, it's going to be a little more mechanical. And it's going to look ugly at first. It will take some getting used to. But it is a paradigm you will use again and again and again. This will become very rote memory before long. Well, mechanical, in fact, sort of your like our shall me void. And I'm going to import inside of these curly braces. Let's go ahead and do printf meow to get the cat to meow. And then to save time, I'm going to copy paste that 2 more times, just like last week. It's obvious. We have literally, but it is a paradigm you will use again and again and again. This will become initialize a very rote memory before long. Well, the most direct translation of this Scratch code to C is probably something that looks a little something like this, whereby I initialize a variable, here called I, and set it equal to 3. That's the code equivalent in C of putting up 3 fingers. Then what I want to do is while I is greater than 0, that is to say, while I have at least 1 finger up, go ahead and do the following. And then once I've done that, for instance, say meow on the screen, I want to go ahead and decrement I and then do this whole thing again. Now, I could have called this variable counter for consistency with earlier, but it turns out it's conventional when you've only got 1 variable involved in your code and all it's doing is something simple like counting. You can go ahead and call the variable I for integer, for instance, but it would not be wrong to instead call I counter. But notice, too, that in this so-called while loop, as we'll start to call it, there is this parenthetical. And that parenthetical is actually itself a Boolean expression. But unlike an if statement, whereby the Boolean expression is evaluated just once, and if the answer is true or yes, you do that thing, the Boolean expression in a while loop here in C is evaluated again and again and again every time you go through the loop to check if you should keep going through the loop. So for instance, if the goal at hand is to say meow, well, of course, the comparable C function is going to be printf, and I want to print out on the screen meow, followed by a new line. Well, what's going on? Well, again, I initialize I to 3. I then check, is I greater than 0? And of course it is, because effectively in the computer's memory, 3 fingers are up. I go ahead and print out meow. I decrement I, which means to put down 1 of those fingers. And then I check the Boolean expression again. Is 2 greater than 0? Of course it is, so I print out meow. And then I decrement I, putting down 1 more finger. Then I check the expression again. Is 1 greater than 0? Of course it is. I print out meow, and then I decrement I, and now I'm down to 0. I check again. Is a 0 greater than 0? Well, no. And so the loop will automatically, by the definition of how this C code works, terminate for me and proceed to any other lines if there are more lines of code that I've written. So how do we actually implement this then in code and get it running? Well, it's going to be pretty much the same idea. Let me go back to VS Code here. I'm going to get rid of all of this copy paste. And inside of my main function, I'm going to do exactly what we saw. Int I equals 3, semicolon. While I is greater than 0, then go ahead and print out with printf, meow, \n. And then be sure you decrement I. And notice that lines 8 and 9 are not only indented, they are inside of that while loop, so to speak, which means they will both happen again and again and again, because what's happening in code here is those curly braces are kind of like the yellow pieces that are hugging the other puzzle pieces in Scratch. It will keep doing this, 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 but every time through that loop or cycle, this Boolean expression will be checked again and again and again. until the answer is false, at which point the computer is going to jump to the last line. And if there's nothing left, that's it for the program. No more to be done. So same exact idea in Scratch, even though it's a little more mechanical. So that's how we might implement this. And you can think of it sort of to be again and again and again until the answer is false, at which point the computer is going to jump to the last line. And if there's nothing left, that's it for the program. No more to be done. So same exact idea in Scratch, even though it's a little more mechanical. So
I see.
implement this. And you can think of it sort of these variables. This is perhaps a little gratuitous, but let's do this. So if you have a variable inside of a computer's memory, and that's a detail we'll get to in more detail before long, you can really think of it just as like a container that stores values. So for instance, this clear plastic bowl, it can be thought of as a variable. It just stores values. And right now there's obviously 3 stress balls in it, so it represents the number 3. So what's really happening in code like this is we've initialized I to 3, which is this bowl. We're then checking the question on line 6, is I greater than 0? Obviously. So we proceed inside of the curly braces and we print out meow. We then decrement I. So for the sake of unnecessary drama, like that's decrementing the variable. So what's being stored in this container now is 1 less. We do it again, check the count. Nope, 2 is greater than 0, so we keep going. Meow, decrement I. Check the variable. 1 is greater than 0, so we print meow, decrement I. We check the condition again. I is not.
Que mais? Makes game important. It's more than 2. And if it's more than 0, it repeats the process. And once it gets to 0, it gets really good. I equals equal 3.
Zero is not greater than 0, and so the rest of the code stops executing. I'm not sure if that was any more effective than fingers on my hand, but we had the ball, so same exact idea. Variables are just storing some value, and incrementing and decrementing would just be adding or subtracting stress balls in this case. But there's other ways we could do this. In fact, let me zoom in on my code here. And it's not really conventional in programming to count down. Like, nothing wrong with it. It's just not really a thing. We would typically count up. So we could alternatively do this. Set I equal to 1 initially. So we count 1, 2, 3, like a normal person. And we can change our condition. If I'm going to count from 1 to 3, what should my comparison be in my Boolean expression here? I is less than 3? Less than or equal to 3, I think. So if I is initialized to 1, we're going to go through this 1 time, 2 times, 3 times. I is going to eventually get incremented to 4, but at that point, 4 is not less than or equal to 3, so it's only going to execute a total of 3 times. But there's still a bug in this code. What other line needs to change? Yeah, so line 9 needs to become plus plus. So this code is just as correct, and honestly, reasonable people will disagree. Your TF might say do it this way and not this way, but like this is still correct, but it's not the most conventional way. As per last week, computer scientists and programmers generally actually start counting from 0 by convention for reasons we'll soon see. So the better way, the more conventional way, arguably, would be always start counting from 0. Count up to, but not through the number you care about. And so this form of the code is probably the most popular way to do it. Start at 0, count up to 3, but not through 3, as with less than or equals than. All 3 are correct. Can't really do counting up as easily with the bowl without picking up the balls, but the exact same logic applies. And in fact, this version of the code is so commonly done that there's a different way to implement it all. There's a similar way to implement it all together. In fact, this code here, same exact thing, repeating 3 times, because it's so commonly done that you want to initialize something to 0 and keep doing something until like the value 3, you can actually use a different preposition for, which is another keyword in C, and it looks a little more cryptic, but it just tightens things up. This is what's called a for loop. Previous is what's called a while loop. And honestly, even though it probably to the newbie still looks just as cryptic, it's just a little tighter because you're expressing all of these ideas on one line. You specify the variable you want to create and initialize. You specify the Boolean expression you want to check again and again. You specify what increment or decrements you want to happen. And confusingly, you do use semicolons here, not commas. You do not put a semicolon here. You, of course, don't put them after these things. You generally only put them after functions thus far. So and probably to the newbie still looks just as cryptic. It's just a little tighter because you're expressing all of these ideas on one line. You specify the variable you want to create and initialize. You specify the Boolean expression you want to check again and again. You specify what increment or decrements you want to happen. And confusingly, you do use semicolons here, not commas. You do not put a semicolon here. You, of course, don't put them after these things. You generally only put them after functions thus far. So we do have one semicolon here. But in short, this you'll get more comfortable with. This is how I, for instance, almost always write a loop. But it's doing the exact same thing mechanically as this. Same thing as counting on your fingers. Same thing as counting the stress balls. There's just different ways to express the exact same idea. But there are ways to screw up. So in fact, let me go ahead and do this. Suppose that we'd like the cat to live as long as possible, and we don't want it to stop meowing after just 3 or a finite number of times. How can you do something forever, again and again and again? Well, let me go back into VS Code here. Let me delete all of the code from earlier. And let me go ahead and say, while something is true, I'll come back to that. Let's just go ahead and print out meow, \n, ideally forever. But what do I want to put in here? Well, if I want to do something forever, I could do something kind of stupid like while 1 is less than 2, which is always going to be the case. Or while 50 is less than 51, which is always going to be. I could just ask an arbitrary question, but like arbitrary, not good in general. Like you should have meaning behind your code. So if you want the expression to be true all of the time, just say while true, because true is not changing anytime soon. If it's literally true, it's always going to be true. The only caveat is to use this trick for now. You will need to include the CS50 library, which for today's purposes makes that possible. But there's a problem, of course. If the cat's going to live forever, if I do make cat /cat enter, like you can very quickly lose control over your terminal window, and you can see like the meows are flying across the screen, at least based on the bottom from what we're seeing. Like this cat will never stop meowing. And this is either a feature or a bug, so to speak, depending on how long the cat here should live virtually. But how do you terminate a program that is out of control like this infinitely? So one of the takeaways for today is Control-C is your friend for cancel or interrupt the program. If you ever sort of lose control over a program because you've got intentionally or unintentionally an infinite loop, you can go into your terminal window, hit Control-C, sometimes multiple times if it's ignoring you, and that will break out of the program and just essentially force quit it, like in Macs or PCs. But let's make one improvement here still. The last thing we did with our cat in Scratch, before now we'll take a break in a moment, was we defined our own functions. And recall that we did that to abstract away the idea of meowing, because Scratch didn't come with a meow puzzle piece. C definitely does not come with a meow function. We have to implement it ourselves. So quickly toward the end of week 0, we did this. Define a function called meow that just plays the meow sound. And now we have a meow puzzle piece we can use and reuse. In C, we're about to do this. And this is going to look a little cryptic, but it's going to lay the foundation for future weeks when we do this even more. I've got a meow function, weird mentions of void. That just means there's no input and there's no output for this function. It just does one thing simply, and that one thing is printf meow. So how do I use this here code? Here in Scratch is how we used it last week. When the green flag is the meow function. In C, it's going to look like this. Int made void and all of that. And I can use a for loop, a while loop. I'm copying and pasting the for loop version of the code. Set I equal to 0. Make sure it stays below 3. Increment it on each iteration or cycle. And just call meow. So what's nice here is that we have fairly simply a way in C to create our own functions called meow or anything else that lines up perfectly with what we did in Scratch. We'll take some time to get comfy with the syntax and remember it, have to look it up frequently for reference, but let's go ahead and actually do this. If I go back to VS Code, clear my screen, let me hide my terminal window temporarily, let me go ahead and invent this meow function. Per the code earlier, I'm going to go ahead and do this. Void meow void. And again, the two voids mean no input, no output. It just does one thing well. Printf, quote unquote, meow \n. And now down here, I can use a for loop. So for, and I know this from memory, int I equals 0, I less than 3, I plus plus. And then inside of curly braces, I'm going to go ahead and call the meow function. Notice when I'm creating the function up here, I explicitly, pedantically, no input, no output. When I use the function on line 13, you just say open parenthesis, close parenthesis. That's the equivalent of a Scratch puzzle piece without a white oval. You just put nothing there. You don't put the word void. So that's it. Let me open my terminal window. Let me run make cat to rerun or to recompile /cat, and I think I have a working cat. Now, this is correct. The only thing I don't love about this version, if I hide my terminal window, is that when I start writing bigger and bigger programs, it'd be nice if my main function, which I told you to sort of take on faith for today, is at the top of the file, if only because, like, literally the name main means this is the main part of my program. It'd be nice if it's the first thing I see. Which is to say, just to be pedantic, it's very common to put any functions you write at the bottom of your file, maybe alphabetically, maybe organized some other way. But you put main first by convention, just like the when the green flag clicked. It was the first thing you always started with last week. But watch what happens now. If I go into my terminal window, and Command or Control J is hiding and showing it if you are curious, but probably you'll just leave it open on your own all the time. Let me do make cat again. And I've screwed up somehow. All I did was move the meow function from top to bottom, and I'm getting call to undeclared function meow something, something, something. Well, what's going on? Well, C is pretty naive and simplistic. It's only going to do what you tell it to do, and it's only going to do things top to bottom, left to right. And unfortunately, on line 8, you are telling C, call a function called meow. But that does not exist in CS50's header file. That does not exist in standard IO's header file. It exists at the bottom of my file, at which point it's too late because I'm trying to use it before it exists. So I could just undo that and put this meow function at the top of the file, but you're going to eventually get into a perverse scenario where you can't put all of your functions above all of your functions. Like, you got to pick a lane at some point. So the solution to this, albeit a little weird, and the one time in CS50 and programming that it is encouraged and necessary to copy paste, is what you can do at the top of your code, be above main, is just copy paste the first line of your own function. This is the so-called prototype of the function, and it simply describes how to use the function. And funny enough, we actually saw this earlier, but I sort of, swept it under the rug a moment ago, or a bit ago, when we looked at standard.io.h and we looked at the printf function in the manual pages. I highlighted the header file, but I also glossed over the so-called prototype, which is, the first line of the printf function, just as this is the first line of my meow function. This is like a little clue. This is like saying to C, hey, there's going to be a function called meow that takes no input, has no input, takes no input, has no output. Just know that it exists eventually. And that will satisfy the compiler. Because if I go back to my terminal, rerun make cat, it now knows on faith, per line 4, this function will eventually exist. And indeed, once it gets to the bottom of my code, line 14 onward, there it in fact is. So you just copy the one and only first line of your function's code to the top, called a prototype. And now if I do /cat, I get, finally, meow, 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 yet again in this case. Questions on these here cats? to the bottom of my code, line 14 onward, there it in fact is. Cat, it now knows on faith per line 4, this function will eventually exist. And indeed, once it gets to the bottom of my code, line 14 onward, there it in fact is. So you just copy the one and only first line of your function's code to the top, called a prototype. And now if I do /cat, I get, finally, meow, 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 yet again in this case. Questions on these here cats? No? All right, then the last flourish, before I keep promising cookies, and I promise they exist. So last flourish, like just as we did in Scratch. So in Scratch, recall that we parameterized our meow function by letting us tell meow how many times to meow, so that we didn't need to use our loop inside of our when green flag clicked block. In other words, if I want to actually have the cat meow a specific number of times, I can actually go ahead and do that proactively with some of my own code, such as this here in Scratch. When I edited my meow function last week in Scratch, I specified that I want it now to take an input called n, which represents some number of times. And I changed my repeat block not to be 3 perpetually, but to actually have n generally baked in there instead. Or actually, instead of just saying play sound meow, I had a repeat block using n as the placeholder instead of a hard-coded 3. So how can I now use this in C? In C, it's almost the same. It's still void at the beginning of my function name, which means no output still. It only has side effects. But what did change vis-a-vis the previous version of meow? What has changed? Exactly. Instead of saying void a second time in parentheses, it literally says int n inside of those parentheses, which means in C, this function called meow takes input. It means the exact same thing as the pink on the left. And again, this is why we keep emphasizing the scratch blocks. Like, no new ideas with a lot of these features. It's just different syntax that you'll get used to over time. So if I go back into VS Code here and I change this function, let's do that. Let's change my prototype to be int n, where n represents some number of times. Let's change the actual function on line 14 to also have int n here. And let's actually move the for loop from main into the meow function, such that I now have my curly braces here. I have my print statement inside of those curly braces. And now in main, I can get rid of all of that code, just say meow any number of times, like 3. And just like I did with Scratch, let me hit enter an arbitrary number of times, sort of out of sight, out of mind. Now the essence of my program is like one real line of code, meow 3 times, because I've abstracted away the idea of meowing and told the cat instead exactly how many times to meow by way of that function. OK, I can't keep stringing along cookies so long. Let's go ahead and take a 10-minute break here. And when we come back, more cats, more code. All right. So we are back. So meowing and sort of out of sight, out of mind. Get rid of all of that code. Just say meow any number of times, like 3. And just like I did with Scratch, let me hit enter an arbitrary number of times, sort of out of sight, out of mind. Now the essence of my program is like one real line of code, meow 3 times, because I've abstracted away the idea of meowing and told the cat instead exactly how many times to meow by way of that function. OK, I can't keep stringing along cookies so long. Let's go ahead and take a 10-minute break here. And when we come back, more cats, more code. All right. So we are back and want to add one final flourish to this program, because now, more so than a lot of the examples, like now the programs are starting to grow in length. And indeed, soon there'll be a few dozen lines of code, which is not uncommon. But let's suppose that we want to stop hard coding 3 everywhere and actually prompt the user for some number of meows here. Well, let me do this. In VS Code, I'm going to go ahead and get rid of this one line for now. And let's do some. Let's ask the user for an integer. So int, maybe n for number equals get int. And we'll say something like just number to give a number of meows. And then we'll go ahead and actually call meow, passing in. Not 3 this time, but passing in n. So we are using the return value of getInt to store it in a variable called n on line 8. And then we are passing n as the input or argument to the function called meow on line 9. And again, the actual implementation of meow on line 22 onward, like who cares, out of sight, out of mind. once it exists. We can sort of abstract it away mentally, but I'll keep it uptight here anyway. All right, so let me go ahead and open my terminal window, make cat, /cat, number. I can still type in 3 and it works, or I can go ahead and type in 5, meow, 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 but it's not actually meowing 5 times. Why? I didn't realize this either, but there's a bug. Yeah, exactly. So the for loop, when I copy pasted it before break, I actually kind of got lazy and I forgot to change the 3 to an n so that it matches the name of the argument that's being passed into meow. So that was a bug, unintentional on my part, but we have now fixed it here. And now we are passing this in from main to meow. So if I make cat, /cat, and type 5 this time, I indeed get 5 meows. But it's worth noting there's some subtleties here in my code in that I've used n a couple of times. So this is actually deliberate that I've used n twice in this way to induce a bit of confusion. But it turns out this n is actually not the same as this n, nor this one. So what's going on here? Well, it turns out in programming, there's often this idea of scope. And long story short, generally speaking, variables only exist in the scope in which you create them. More down to earth, variables only exist inside of the curly braces in which you define them. So for instance, suppose I got a little sloppy, and suppose I didn't bother giving meow an input, and I didn't bother giving its prototype an input, and I just used n on line 14, because why? Well, I already defined n on line 8. So this is just an alternate universe in which I'm not changing meow to take input. I'm just using n in 2 different functions. In main, on line 8 and 9. Actually, I don't even need that. On line 8 and 9, and also again on line 14. This code will not work. Like, the compiler will not like this. Why? Because n does not exist inside of meow. Why? Per the heuristic I offered, n exists only inside of the curly braces in which it was defined, namely these curly braces here. So n is in scope in main, so to speak, but it is not in scope in meow. And that's why we kind of have to jump through these hoops and use inputs and outputs and inputs and outputs and pass things around among functions without sort of sharing things across functions instead. Now, I could clarify this and maybe change my argument here from n to like times. If I want to make clear that, oh, this is the number of times I want meow to be said, I don't have to use n for both, but just realize that if you do, it's just a coincidence. They are not usable in 2 different scopes. All right, let's do one other thing though. Let's not only prompt the user for the number here. Let's make sure that it makes sense what number they give us. So if I do make cat, just to clean things up, /cat, suppose I type 0. OK, I suppose that's correct. If I say meow 0 times and it doesn't meow at all, that's arguably correct. But if I type in something like -5, it ignores me, which I guess is better than crashing or freezing or something. But like, ideally, it might be nice to handle this situation. And if they give me a negative number, prompt them again for a positive number. Prompt them again for a positive number. Like, make the program make sense. So how could we do that? Well, a couple of ways. If I go back into my code here, I could do this. I could maybe do something like a loop, or let's see. So if I get n, so if n is less than 1, then it makes no sense. So what do I want to do if n is less than 1? Well, I could just prompt the user again, and I'd say, OK, let's get n again. And then I can say, if n is less than 1, what do I want to do? I guess we could ask the user again. And then if n is less than 1, I could just, again, like I can give them like 3 tries, 4 tries to get this right. Like, this is obviously stupid. Like, I'm copying and pasting. I'm repeating myself. There's no end in sight. Like, I can't do this forever, surely. So this just feels like the wrong solution. So there are different ways to solve this problem. And funny enough, like a while loop is not really the best way. A do-while loop is, damn it. A while loop is not the best way. A for loop is not the best way. It turns out there's one other type of loop that we wanted to introduce that's super useful for getting user input, potentially again and again and again, so that the user cooperates. Specifically, what I'm going to do is this. I'm going to literally say do the following while something is true. So it's more of a mouthful. I'm spreading it out over multiple lines. But what am I going to put inside of the do block here? I'm going to say int n equals get int and ask for that number as before, close quote, semicolon. And I'm going to keep asking while, sorry, accidental enter, while n is less than 1 semicolon. So notice the semantics of this. Even though it's a little weird looking, it does read in English. Do the following, OK, get an int stored in n, and keep doing that while n is less than 1. But this code, as written, is not quite going to work yet. Let me try opening my terminal window, make cat enter. Oh, damn it, like use of undeclared identifier n. Well, here's where the line number is helpful. The line number is indicated here, 12, and it's repeated here, 12. So I clearly screwed up at line 12. There's not that much going on at line 12. Why is n undeclared in line 12, even though I literally just declared it in line 10? Exactly, because I declared n inside the scope of the do block, so to speak, inside the curly braces on lines 9 and 11. That variable n no longer exists by the time we get to line 12. It'd be great if it did, but it doesn't, because it violates that heuristic I proposed, which is that variables only exist in the scope of the curly braces in which they were defined. So how do I fix this? Well, it turns out you can declare a variable in advance outside of one scope, but then define it, that is, initialize it elsewhere. So the solution here is actually this. Inside of the loop, just set n equal to the return value of getInt. But per the heuristic, you've got to declare n, make it exist inside of the outermost scope of this function. So it's a little weird, and we're kind of breaking this down into 2 steps, but this is valid, recommended, correct C code. You declare a variable without giving it any value initially. And then in line 11, you proceed to give it a value, potentially again and again and again. Now, what's useful about a do-while loop? So a do-while loop is the name. So it's a little weird, and we're kind of breaking this down into 2 steps, but this is valid, recommended, correct C code. You declare a variable without giving it any value initially, and then in line 11, you proceed to give it a value, potentially again and again and again. Now, what's useful about a do-while loop? So a do-while loop, as the name implies, will do something no matter what, but it will potentially do it again and again and again while some question is true, like n being less than 1 in this case. All right. As an aside, why did we not do a while loop? Well, let's think about that. While n is less than 1, but wait a minute, n doesn't have a value. OK, so I guess we have to go back to doing getInt number colon semicolon. OK, but while n is less than 1, we're back to the same problem where we have to like repeat ourselves again. So this is why for loops, while loops, not the right solution when you want to do something at least once, but potentially again and again. So the right solution here again is this new and final looping construct. I'm just hitting Control Z a lot, whereby we've done it as follows. All right, let's try this. Clear the screen. Make cat, enter, /cat. Let's type in 5. Still works. Let's type in -5. And notice it doesn't just ignore me. It prompts me again and again and again. Even if I type in 0, I've got to at least give it a positive integer. Well, this actually seems like kind of a common paradigm. Like, what if we want to prompt the user for a positive number in other programs too? You know, we're nearing the point already, even after just week 1. It'd be nice to like write our own reusable functions that solve common problems. And eventually maybe we can put them in header files as well. But for now, let's go ahead and do this. I'm going to actually copy all of this code, and I'm going to create one more function in this file below main called getPositiveInt for integer. And I'm going to specify all of this code. And I'm going to create one more function in this file below main called getPositiveInt for integer. And I'm going to specify that it doesn't need any inputs, because the only thing this function is going to do is that exact same thing. So notice that I've just moved my code from main into a function that's name describes what it does, getPositiveInt. I'm declaring n here. I'm doing this again and again, and I'm doing that while n is less than 1. And what am I going to do up here? I can do something like this. Give me a variable called times, for how many times do you want to meow, and just call getPositiveInt. semicolon. So now again, we've abstracted things away, and just like in Scratch, our final example, which recall looked a little something like this, where we just called a function to meow 3 times. Now we're calling a function to get text. If I hit enter an arbitrary dramatic number of times, out of sight, out of mind, I now have 2 functions in this world, getPositiveInt and meow, that are collectively implementing this entire program. But it's not quite correct. There's one mistake here still. Notice that getPositiveInt is written slightly differently from the meow function. And just to be clear, too, let me copy its prototype to the top of the file, just so we don't make that same mistake I made earlier where I didn't put the prototype at top, so C didn't know what it was. What is different about these 2 prototypes at a glance? Yeah? OK, so getPositiveInt apparently, and we've not talked much about this, apparently does have an output of type integer. It's supposed to return an int, hand me back an int. It doesn't have any input. That's what the void in parentheses meant. No input, but yes output. And meow, funny enough, is the opposite. Yes input, no output. Why? Because it has a side effect, the visual thing, where it prints something to the screen, but doesn't hand me any useful value back like the ask function or the ask puzzle piece did. So these are sort of opposite in functionality, which means I actually need to return an integer from this function to whatever function wants to use it. So if I want the assignment operator to work here on line 9, I need to do what all this time getInt, getString, and other CS50 functions have been doing. I need to, in my own function, return that value, literally with a new keyword called return. And this is why I keep sticking out my hand. When you want a function to like hand you back a value, you literally use return and then that value. That's why we have return value as a term of art, literally the return keyword. So if I open my terminal window now, make cat, enter, value. That's with a new keyword called return. And this is why I keep sticking out my hand. When you want a function to like hand you back a value, you literally use return and then that value. That's why we have return value as a term of art, literally the return keyword. So if I open my terminal window now, make cat, enter, I did screw up accidentally. How? Yeah, so on lines 9 and 10, I made a quick change. I changed my variable to times, but I stupidly didn't change this. So that's fine. That's why n was undeclared in that context. Let me clear my terminal, make cat once more. OK, that worked. /cat. Let's type in 5, and it's still working. So again, even though the code feels like it's, even though the code is kind of growing and growing and growing, it's the exact same program we wrote super simply before break, but now we're sort of modularizing it. We're creating reusable functions. And this is why functions like getString exist, getInt exist. Like CS50 wrote those years ago. And we realized, why are we copying and pasting these functions in all of these different CS50 programs? Let's factor out that functionality into a function of our own, getInt, getString, just like here I'm proposing to factor out this functionality, get a positive integer that gives you even more precise functionality. So theoretically, you could use and reuse it in other programs too. By not even just putting it here, we could go put it in a file of your own name and include it in future programs as well. Like that's all a library is. Someone realized, geez, other people, including myself, might find this function useful again and again. Let's package it up in our own custom functions, just like our custom meow puzzle piece last week, so we can indeed use it again and again. And the takeaways for now is that unlike Scratch, which was a little more user-friendly, in C, you have to specify if you want your functions to have inputs, and you must specify if you want them to have outputs as well. But more on that syntax to come. So where does that bring us? So after all this discussion of code, like at the end of the day, like this is what's important in the world of programming. Not surprisingly, it's like what's important when it comes to grading and evaluating the quality of code. One and first and foremost is correctness. Like if the code does not do what it's supposed to do, what was the point of writing the code? So correctness sort of goes without saying. Design, again, is much more qualitative. It's like getting feedback again on an English essay where reasonable people might disagree. You can make your argument better. You can structure the paper better. You can structure the code better in the case of programming. And style is purely aesthetic. Does it look good? Is it pretty printed, so to speak? Can other people, colleagues, future, and classmates present actually read and understand it? That's what we mean by style. Nicely enough, within CS50's programming environment, you will have tools to evaluate the quality of all three of these axes, so to speak. So in problem set 1 onward, you'll be introduced to a command line tool that you type its name at the prompt called Check50 that will check for you the correctness of your code. Not necessarily exhaustively, like there might be mistakes you've made that we don't catch, which doesn't make your code correct, but it is a tool for finding many of the mistakes in your code. In the real world, you would have colleagues or yourself would write tests for code you wrote or someone else wrote. So like testing code is not just a grading thing. It is a real world thing to ensure that systems are designed correctly. We saw the Style50 tool in VS Code already. You click the Style50 button. There is now, thanks to the duck, a Design50 button too, also in that top right-hand corner, whereby once your code is correct and working, like several of my programs have been, you can click Design50 and the duck will not just quack, but give you qualitative advice, if it can, on how you can make that code even better even before you submit. And of course, there's all of us humans in the room and online that you can ask these same questions of as well. So let's now solve some sort of real world, but still simple problems as opposed to emphasizing small bite size as we have thus far. So the first of these programs falls into this category of having side effects. So let's implement one or more functions that takes an argument's inputs, and as its output produces these visual side effects. We'll draw inspiration from Super Mario Brothers, not surprisingly perhaps here. The original one, which was very two-dimensional, side-scroller, left to right. Mario or Luigi move from left to right and generally have to like jump over things like pyramids or other shapes on the screen. So how might we go about implementing some of the screens from Super Mario Brothers, albeit textually? Well, we'll make it a little black and white and ASCII art, so to speak here, using just our keyboard. But suppose we want to write a program called Mario.c that just prints out 4 question marks. It's not going to be nearly as pretty as what's on the screen here, but the logic is going to be the exact same as what Nintendo presumably did years ago. So let me open VS Code, my terminal window. Let's code a program called Mario.c. In Mario.c, I'm going to kind of start with some boilerplate. I know I want to print, so even if I don't know how to do this yet, I'm going to include standard.io.h. For today's purposes, I'm going to copy, paste, or type out that same line again and again, int main void. And inside of my main function, akin to the green flag being clicked, I want to go ahead and print out 4 question marks. Well, honestly, the simplest way I can think of doing this is with printf, question mark, question mark, question mark, question mark, maybe a \n to move the cursor, and that's it. So that is arguably correct. So let's do make Mario in the terminal, /Mario, and it's not quite as pretty as the game version of it, but it is in fact the exact same idea. But here's sort of an opportunity, a stepping stone to do better design. Like this game changes over time, and not all of the screens have just 4 question marks. It might be 5, 6, or even more. So what's the right programming construct with which we could generalize how many question marks are printing here? Like what feature of C do we want? Like a loop, like a for loop, a while loop, or something like that. And there's different ways to do this, but honestly, I've proposed earlier that we get into the habit of reaching for loops as just very conventional. So let's do that. For int I equals 0, I less than 4, because that's how many I want for the moment, I plus plus, and then inside of my curly braces there, let's go ahead and print out, quote unquote, a single question mark, but no new line. Let me now go ahead and make Mario. And can you anticipate a arguably aesthetic bug when I hit enter? It's not going to move the cursor to the next line. But the solution here is a little non-obvious. I don't think this helps me. If I put the \n there and I do make Mario again and /Mario, what is this output going to look like instead? Yeah, like a vertical column of question marks, which, while nice enough, is not the goal at hand. The goal is these horizontal ones. So someone else, what's the fix here if clearly putting the \n inside of line 7 is wrong? Yeah, so put it after the loop, and not after the printf line specifically, after and thus outside of the loop, so that after that loop is finished executing 3 total times, it's totally fine to just print nothing other than a \n, so long as we now recompile the code, make Mario, /Mario, and voila, now we have 4 in a row. It's a little generalized. OK, so we've sort of plucked off a fairly easy problem. Well, let's go back to the world of Mario and try something that is, in fact, vertical like this. So this is another scene with like 3 bricks here. Instead of using question marks, we'll use hash symbols to represent bricks. This actually is the incarnation of my mistake a moment ago. So let me undo this by getting rid of that printf. Let me change the inside one from a question mark to a hash symbol, which looks the most similar in ASCII to a brick. And let's go ahead and put in \n after that. If I do go ahead and do make Mario, /Mario, it's not that interesting, but, and it's actually not that correct because I wanted 3, so no big deal. I can, of course, go back to my code and change the 4 to a 3, or better yet, I could use getInt or my new getPositiveInt function and just generalize this further so that I can print out any number of them. But for now, /Mario gives me 3. All right, so we've plucked off the second of 2 problems. Let's now let things escalate a bit. So it turns out once you get to like world 2 and beyond, there's some underground parts of Mario where you actually have bigger, more solid bricks like these here. And just by eyeballing it, this is like a 3x3 grid of bricks, like 9 of them total, we'll conjecture. So how can I go about implementing this? Well, now is where the program gets a little more interesting. And the sort of not correct, well, the poorly designed way to do this would be like printf ###n semicolon, and then maybe printf. Like that's kind of like correct, but not well designed. So make Mario /Mario. You know, it doesn't look like a square just because these hashes are more vertical than they are horizontal, but it is correct, this example, but it's not very generalizable. And this is like literally hard coding. I copy pasted. I'm just doing a lot of bad practices here. So what could I do instead? Well, it turns out we can combine today's ideas, including loops, to do things again and again. So what is this grid of bricks? It's a 3x3. So that's like, you know, it's like a row and a row and a row. And then within each row, there's like column, column, column. So it too is like an old-timey typewriter that sort of prints one line, then the next line, then the next line, and so forth. So how can we conjure that in code? Well, let me go ahead and do this. I think a print approach would work is like this. For int I equals 0, I less than 3, I plus plus, because I know I want to do something 3 times. But what do I want to do 3 times? This loop kind of represents in my mind's eye row, row, row. So in fact, I could be more pedantic. If I want my I to mean something beyond int, I could say row equals 0, row less than 3, row plus plus, just to help me think about it. And then what do I want to do on each row? What do I want to print? Like column, column, column. So brick, brick, brick. So how do I print 3 bricks or any number of bricks? Well, I could kind of cheat and just do printf ###n. But again, I can't generalize. I can't take an input from the user and print 4 or 5 or 6 bricks. So that's going to get me into trouble eventually. So maybe I could use a loop. So I could do like for int I equals 0, I less than 3, I plus plus inside of my loop. And then in here, I could print out 1 hash. And that's kind of on the right direction, the right path, because now I'm just using the simple building block or brick, but reusing it again and again. And it's totally fine to have nested these columns in this way. I used I out of habit, but what would a better name be? Well, maybe column, or maybe just COL, call for short, so that my code is sort of saying what it does for me. And I don't have to use row or column explicitly. I don't need to print them, but I am using them as counters, one after the other. So let me go ahead and run make Mario, /Mario, and I'm feeling good about this, but damn it, there's 9 bricks, but they're not. Why? What's the fix? Yeah. Yeah, I never went to a new line. And let me do what I think you're not going to suggest I do. Let me just go to the obvious place. All right, well, let's put one right after the brick. But of course, if I do make Mario, /Mario, I'm making the same mistake as before. I'm printing out too many new lines. So in between what lines do I actually want to print a new line? Between, yeah. Yeah, so 10 and 11. So outside of the inner loop, but inside of the outer loop. So it happens again and again. So let's just print out as before a single \n semicolon. Now let's do make Mario, /Mario, enter. Now it's generalized as I see fit. And if I really wanted to dwell on this, I could go in and I could prompt the user with getInt or with getPositiveInt, figure out what row and or column should be. We can make any size brick that we want, but now we have sort of a nice starting point. But there's another way to think about this, because I dare say, especially for like your first CS50 problem set, if you're trying to print bricks in the world of Mario in this way, it's probably not going to be obvious to come up with loops like this and just magically get it working after like 45 seconds in total. Like it'll be a struggle at first, but To follow. So one, it's pretty conventional.
Mano, é só suco com energético. Foi o que eu falei, não é gin não, doido.